See, if you take three-phase system, what is the nature of resultant MMF? Resultant MMF is rotating in nature. If MMF is rotating, you can assume that MMF is function of the current only. Net current is also rotating. But see, mathematically, if you verify, A phase, if you add A phase, B phase, C phase current, net current becomes 0. If net current is 0, it means that net MMF is also 0, right? But see, our system is a complex system, AC system, right? Resultant current or resultant voltage, resultant MMF, all are always rotating in nature, right? So resultant length of the vector, let us know that this is the resultant vector, right? So instead of taking resultant, what I will do is I will take A phase MMF, B phase MMF, C phase MMF. Why? Because A phase MMF is always fluctuating. Practically the nature of MMF individually always fluctuating. If you add all together, net is rotating. That is the behavior of the three-phase system or two-phase system or five-phase system also. Net MMF is always rotating. Right? Now, see here what I will do is, right? Here I will take reference person. Right? Now, this is my requirement. I want to change the three-phase vectors into two-phase vectors. While converting the, see, whenever you want to change these vectors from three-phase to two-phase, right, you need to take common reference. This is very important. Reference person, thing is here, good thing is reference person. For understanding purpose, here I have taken reference person exactly in phase with A axis. At the same time, right, in this is about two phase. In two phase, right, vectors I will take in phase with alpha is in phase with reference person. This is also one advantage, right? Right. This is about beta. Now, with respect to this person, now we'll try to identify the transformation matrix. This matrix is so important. Conversion matrix is so important while transferring the signals from variables from three phase to two phase without losing any property, right? So here what I will do is, with respect to this person, what is the mathematical model for A? With respect to this person, how we can represent A? Let us know that this is FA, FB, FC, this is F alpha, F beta. A phase MMF, B phase, C phase MMF in three phase, F alpha, F beta in two phase. Now, how we can express net MMF produced by three phase with respect to this person? Whenever you want to calculate net MMF with respect to this person, reference person, common person between three phase and two phase, right? You need to take care about what is the space displacement angle between reference person and individual vectors. Now, so from this, with respect to this person, right, in three phase, net MMF is FA into e power j0. Why e power j0? Space displacement angle between vector and reference person is 0. That's why angle is 0. Now, next plus FB into FB leads the reference person. Reference person is here. FB leads the reference person by 120 degree. FB e power j 120. Clear? So plus FC e power j plus 240 or minus 120, both are same. So this is the mathematical model, right? This is the resultant MMF produced by the net MMF produced by three phase system with respect to this person, right? So this MMF, and so with respect to this person, what is F alpha? F alpha into e power j 0 plus F beta e power j 90. Solve this equation. Do first. Tell me what are the real components, what are the imaginary component. Now here thing is FA, FB, FC are known values. Please try to understand. FA, FB, FC are known values. F alpha and F beta are unknown values. Multiply, solve. see what is mathematically, what is e power j, what is e power j? Theta. Cos theta plus j sin theta, right? So fa into cos 0 plus j sin 0 plus fp cos 120 plus j sin 120 plus fc cos 240 plus j sin 240 equal to f alpha cos 0 plus j sin 0 plus f beta cos 90 plus j sin 90. What is the advantage here? Tell me. See, here thing is, next one more important thing is FA, FB are under your control. FA, FB practically these two components are not existing in the actual system. You got my point? But without losing property, with respect to control point of view, three-phase variables, we can convert it into two-phase. While converting the variables from three-phase to two-phase, if you take space displacement angle between these two is 90 degree, advantage is, what is the advantage with respect to control point of view? What is the advantage? This one, see, this is under your control. This is based on our convenience. We are taking alpha alpha and f beta with 90 degree delay. If you take less than 90 degree, what is the issue? Later you can check. Mathematics, it is mathematics only, right? If you take less than 90 degree, what is there? See, calculating f alpha and f beta in terms of FA, FB, SC, FC will become more complicated. Why? Because decoupling is not possible. By taking 90 degrees between f alpha and f beta, we can calculate f alpha, f beta effectively. Within 2 steps we can calculate. Otherwise, if it is less than 90 degree, if you want, you can try. Real side f alpha and f beta will enter. Imaginary side also f alpha and f beta will enter in the equation. Calculation is more complicated. See here. Now, see, if it is a 90 degree, what is the advantage here? Tell me. If it is a 90 degree and 0 degrees, one vector is in phase with reference person, another vector is perpendicular to the reference vector. These two are artificial signals. These two are so important with respect to control point of view. Without losing any property, right, what we are doing is we are converting the signals. Now, while converting the signals, you need to take care about the space displacement angle between the two vectors. If it is a 90 degree, advantage is, now here sin 0 how much? 0. If it is a 90 degree, f beta is 90 degree away from the reference person, advantage is this component becomes 0. You got my point? So, with respect to this equation, imagine a real component will eliminate it. With respect to this equation, imaginary component will eliminate it. You got my point? So, from this equation, separate real and imaginary component. Do first f alpha and f beta, separate real and imaginary component. FA, FB, FC. So, cos 0, cos 120, cos 240, sin 0, sin 120, sin 240. You got my point? But thing is, this is not a symmetrical matrix. See, technically, right, these equations are fine. Based on our assumption, based on our two-phase vector position, you got this equation. But mathematically, this is not a symmetrical matrix. That's why you have to take something else here. This is a way. These values will play key role whenever you want to adopt magnitude invariant and power invariant condition. You got my point? See, in today after session, I will forward one video lecture. Go through it. You will get clarity about transformations. For all participants, I will forward, go through it. You will get more clarity about the significance of this third row. Right? Everyone understood here? But in textbook, what they are doing is reference person, they are not taking in phase with A axis. Let us assume that reference person is leading or lagging. Issue is what is happening, theta will enter. Some angle is entering this equation. Right? See, that's why if it depends on the space vector concept, right, extracting the transformation matrix, it is not a big deal. So example, see, by taking this example, you can understand what is the significance of this complex vector representation. You will get more clarity. If it depends on the complex vector representation, e power j operator, it is not a big deal to extract the transformation irrespective of the reference person. If reference person is somewhere else, also no issue. Right? This is FC. Now here thing is this is F alpha, this is F beta. Right? Now reference person is here. Our reference person is here. You got my point? Understood? Now tell me. So this is about theta, space displacement angle. Reference person leads the x-axis by theta. Now in this case, anyone please tell me what is the mathematical model for transformation matrix with respect to this reference person. Please try to understand, with respect to reference person must be always in phase with two phase frame. You should not take reference person on three phase. Why? Because controller is designed based on the two phase reference frame. That's why reference person must be standing in phase with two phase axis, so that what will happen, number of variables will come down. Now if reference person is sitting here, then what is the transformation matrix? I will see. Now person, with respect to this person, FA is lagging or leading? Lagging. How we can express FA? If it is lagging with theta, how much angle? So yeah, simply your job is FA you need to multiply with e power minus j theta. You got my point? FA, if you multiplied with e power minus j theta, you will get clarity about what is the effect of FA on reference person in D axis as well as Q axis. You will get clarity. You got my point? Effect of FA on alpha axis and beta axis, you will get clarity if you multiply with e power j theta. Right? Next, what about FB? So very good. 120 minus theta. See, last day there is a this one quiz is there, right? See, I will not ask the question beyond the whatever we are discussing in the regular sessions. We are not asking any questions beyond the class. If you put more attention in the sessions, definitely you will get good score in the examination. Feedback, before giving feedback, you have to write, you have to go through the examination, right? But there is no grade system, right? You got my point? We will not decide any grade. Only this is only for understand the participants characteristics. That's why in browser itself I have not floated any grade option also. For other GAN program, they are offering grade sheets also, right? Please start on. Within 5 days, it is very difficult to understand the concept in detail. At least, see, if you understand the philosophy, it is fine. Later, if you follow this philosophy, definitely your problems it will solve, right? So FC e power 240 minus theta, fine, or 120 plus theta, both are same. So what is the equation? This one is equivalent to f alpha plus j f beta. So finally, in two phase side, you will get one real and one imaginary component if you take 90 degrees space displacement. That's why this angle is so important. This one must be 90 degrees. If it is a 90 degree on two phase side, only two variables are there. Sorry, only one variable is there on real component side and one variable is there on imaginary side. Right? Separate. If you solve this equation, you will get f alpha, f beta equal to, see, cos of theta, cos of 120 minus theta, cos of 240 minus theta, next minus sin theta, sin of 120 minus theta, sin of 240 minus theta. Clear? This is the transformation matrix. But issue is, now here big challenging is, see, what is the base for transformation? I want to ask one important question. Before writing equation transformation matrix, I want to ask one important question. What is the base for any system? What is the base for transformation system? They will take voltage as a reference, or current as a reference, or flux as a reference. What is the base for transformations? MMF. MMF should not vary. Whatever MMF produced by the three-phase system, same MMF you need to take care in the two-phase system also. If you satisfy this condition, right, you will get same behavior of the system. Whatever behavior, whatever system is offering characteristics in three-phase, same characteristics we can extract. Even number of variables are less in two-phase, same behavior we can extract with less number of variables. That is the strength of MMF. See, maintaining constant MMF in two-phase as well as three. Whatever MMF strength is there in three-phase, same MMF we need to produce in three-phase system. Like that, you need to take turns ratio. Here, this one, this is the multiplication factor. Why? Because number of phases are more in three-phase, MMF strength is more. What is the resultant MMF strength? 3 by 2 FM. But in two phase, what is the net MMF? FM, peak value. See, in three phase system, net MMF equal to 3 by 2 FM. What is FM? FM is the peak value of the individual phase signals. Now, two phase system, FM. What is the difference between three phase and two phase? What is the multiplication factor? What is the difference between these two? 1.5 is the difference. You got my point? So there is a difference is there, net MMF. If you balance, if you take care about this one, see, important thing is MMF is nothing but number of turns into current. You need to take care about the current magnitude as well as turns ratio. By taking care about the turns ratio and current magnitude, we can maintain constant MMF after conversion also, right? So what is my request is, I will write equation, I will write formula. You have to substitute in MATLAB and verify whether magnitude is changing or not, whether power is changing or not, we can check, right? So one thing is, so what is the logic behind magnitude invariant and power invariant? I will share video lecture today after session. By 8 o'clock I will share, go through it. You will get more clarity about magnitude invariant and power invariant. Okay. So F alpha, F beta, see, 2 by 3. This is a very important thing, 2 by 3 multiplication factor. Right? If you take 2 by 3 multiplication factor, what is the advantage? What is the thing? Transformation matrix. Whatever matrix we discuss, that matrix you have to substitute K matrix. Then here you have to take three phase variables, FA, FB, FC. Then this transformation is called magnitude invariant. Right? Next, come to F alpha, F beta, right, equal to square root of 2 by 3 into transformation matrix FA, FB, FC. This is nothing but if you multiplied with transformation matrix with square root of 2 by 3, y 2 by 3 in magnitude invariant, y square root of 2 by 3 in power invariant in detail, right? You will get more clarity after going through the video lecture. I will share. I will share after this class immediately. I will give permission. You can access, right, through your email IDs, right? This is about power invariant. Now I will try to show the equations. Same thing. Take photo and try to implement in your system and verify the result, right? Up to here, everyone. Anyone having doubt? Any doubt? See here, take first waveform. Let us that what is my request is in simulation you need to take 3 sinusoidal waveforms, right? Take 3 sinusoidal waveforms from the library direct itself. You can take frequency 50 Hz and magnitude 1, right? After that apply, multiply the signals with 2 by 3 into, take theta 0. If you take theta 0 you will get cos 0 equation, same equation you can take. Later I will tell from where this theta you will get. That is very important in FOC, right? By using FOC theta we are inducing in the transformation technique, so that what will happen, your system, right, order system order equation will become from fourth order to second order. FOC is nothing but combination of transformation, field orientation and V by F. There are 3 logics are required. If you want to change the characteristics of induction motor from 7th order to 1st order, you need to take 3 concepts. One is transformation, another one is orientation, last one is V by F. By adopting these 3 logics, we can change the characteristics of the machine from 7th order to 1st order in case of induction machine. In case of PMSM machine, 4th order to 1st order it will change, right? So here, now tell me what are the conclusion here. Otherwise I will take just a minute. I will take one more. So this is a very important slide for net power invariant condition and power invariant condition. You need to multiply with transformation matrix with this transformation matrix. You need to multiply with square root of square root of 2 by 3, right? Then in that case what will happen, net power will not change. What is net power? Whatever power is resultant power generated by the A phase, B phase, C phase in 3 phase system, if you calculate resultant power, that power exactly matching with power generated by the alpha axis coil and beta axis coil. If you add together, then 2 phase net power and 3 phase net power will balance to each other. So that, see here, take case 1. In case 1, see these signals are 3 phase signals, right? Right, these signals after converting Clark transformation matrix, after now here we adopted magnitude invariant or power invariant. Check, this is about power, 3 phase net power 300 volt amp, right? This is 3 phase system, this is about 2 phase system. This is magnitude invariant or power invariant. Power is constant. Check three phase system. What is the power? Net power. This power you will get after adding, sorry, VA IA plus VB IB plus VC IC. Instantaneous voltage and instantaneous current. If you multiply, you will get instantaneous power. Net power is constant in three phase system. Even if you take two phase, so V alpha I alpha plus V beta I beta, if you calculate, it will give same amount of the power without losing any property. Whatever power generated by the three phase system, same amount of the power we can produce in two phase system also, but necessary condition is you need to take square root of 2 by 3, right? Okay, another example is for phase power invariant. For phase power invariant or magnitude invariant, both are same. For phase power invariant, nothing but, right, magnitude, it will not change. Check here, this is case 2. Another case, magnitude's peak, you can check. In case 1, power is not changing, net power is constant, but if you verify individual peaks, right, it is getting effect. Now, in case of magnitude invariant condition, right, three phase peak voltage and two phase peak voltages, V alpha peak, right, VA peak, both are same. Nothing but magnitude is not getting effect. For phase power is also checked, for phase power it is not changing. But if you add net power, it will get change. Net power is different, 1.5 times less. Please start understand. See, you got my point? So, see, this is the numerical example. Instead of numerical example, so what is my suggestion is, take, so better first initially you can, I will show the diagram, try to implement same thing in your system. Write down. We'll try to focus on we'll take this equation. Net power invariant will take, right? So I alpha, I beta, V alpha, V beta is square root of 2 by 3 into transformation matrix. So in transformation matrix, if you take theta 0, cos 0 1, cos 120 minus 0.5, cos 240 minus 0.5, next sin 0 0, sin 120 root 2 by 3, sin 240 minus root 3 by 2, right? Now take this equation and solve in simulation and tell me same results you have to get. Take this equation, do first. Simulation block for 3 phase to 2 phase. Condition is power should not vary. Net power invariant condition you have to take. First take this picture, otherwise instead of writing you can take photo and do simulation. Writing blocks also it is fine. If you want to write the blocks, if you want to draw the blocks, also fine. Sir, in some papers they have given transformation matrix in different way. No issue. You forget about what is their representation. Where is the reference point is so important in transformation method. What is the speed of reference person is also so important. Fine. So for V alpha, V beta, I alpha, I beta, these are all the equations. So I alpha is square root of 3 by 2 IA, right? What is I beta? I beta is, so what is my request is solve yourself. Take, see, in this case, VA, VB, VC are known values. IA, IB, IC are known values. Unknowns are I alpha, I beta are unknown, V alpha, V beta are unknown. So, by using transformation matrix, we can derive the unknowns in terms of known values. To find the unknowns, right, we can derive the equation, we can solve the transformation matrix, so that you will get see. I will write one for current, I will write remaining thing for I alpha, I will write here remaining thing you have to do. So, from this equation, so I alpha, I beta equal to transformation matrix 1 minus 0.5 minus 0.5. Here IA, IB, IC are known values, right? 0, square root of 3 by 2 minus square root of 3 by 2. From this equation, if you solve, what is I alpha? From this equation, from this matrix, here 2 by 3 is there, square root of 2 by 3 is there. What is the reason behind 2 by 3? You will get more clarity after going to the video lecture. I will forward video lecture, then you will get more clarity, right? I alpha equal to square root of 2 by 3 into, so 1 into IA minus 0.5 minus 0.5 into IB plus minus 0.5 into IC, so minus of 0.5 into IA, IB plus IC. Clear? So, what is IB plus IC? IB plus IC nothing but minus IA. Clear? You got my point? See, IA plus IB plus IC is nothing but minus IA we can write here. These two IB plus IC we can replace with minus IA. Then you will get finally I alpha equal to, what is I alpha? In magnitude invariant condition, sorry, power invariant condition, I alpha is nothing but square root of 3 by 2 into IA. Similarly, V alpha equal to square root of 3 by 2 VA. For currents and voltages, same multiplication factor you have to take care, right? Similarly, I beta, from the equation I beta is square root of 2 by 3, see, 2 by 3 in, plus square root of 3 by 2 IB minus IC. This is the equation. So, from this equation these two will cancel, right? Finally, what is I beta? I beta equal to 1 by root 2 of IB minus IC. This is about I beta. So, I alpha, I beta are known. Similarly, same V alpha and V beta we can write, right? Now, this is about simulation. Now, these three are unknowns. Let us assume that V alpha, VA, VB, VC are known values. If you want to get V alpha, what it required? You need to multiply with square root of 3 by 2, right? Clear? Now, V beta and VC, how to get V beta? V beta is nothing but 1 by root 2 of VB minus VC. This formula you have to write. So, here VB minus VC, right? Then VB minus VC, if you multiplied with 1 by root 2, you will get V beta. Clear? So, first you need to calculate V alpha and V beta, then take sinusoidal currents. Here peak value you can take, what is my request is, you can take peak is 200 volts, peak 200, frequency you can take 50 hertz, right? Time delay between A phase to B phase 120 degree you can take, 120 degrees or 2 pi by 3 radians. Here this one current you can take IA, IB, IC, you can take peak value 1 amp, right? Solve this block, then you will get, see, if you add V alpha into I beta plus V beta into I beta, you will get net power in two phase. This power and see VA, IA plus VB, IB plus VC, IC, if you add for phase, A phase power, B phase power, C phase instantaneous power, this power and this power both will match. That results you have to show before closing today's session. Do fast. So this is about simulation. These three are sinusoidal signals you can take from the MATLAB directly. Peak value, this all are VA, VB, VC. This IA, IB, IC you have to take. Then see, you no need to implement whatever diagram is there in slide. Same thing you no need to implement. You can write another code also. So here you will get net power in 3 phase. Here you will get for phase power, net power in 2 phase. 3 phase net power, here you will get 2 phase net power you will get. Finally, this is nothing but this is this signal, this is V alpha, I alpha, this is V beta, I beta. So V alpha, I beta you need to multiply, V alpha, I alpha you need to multiply, then you will get net power in 2 phase. Next here VA, IA you need to multiply, VA, IA you have to multiply, you have to get VB, IB, you have to get VC, IC, you have to get, add all three per phase powers in 3 phase, then you will get net power. These two waveforms, if you observe, both will give same result. If you take care about the multiplication factor for transformation matrix, square root of 2 by 3 if you take, net power will not change. See here, check, there is no change in the net power. Output power is same. Power will not change. But here, verify what is the peak here. How much peak they have taken in 3 phase? 220. But after converting the signals from 3 phase to 2 phase in power variant condition, power invariant condition, how much? It is closely to 300. Magnitude it is getting effect, but power it is not getting effect. Right? So open your system, do fast, then we'll wind up today's session. You can take randomly. See, you no need to produce same 300 all time. Right? You can take magnitude of the current whatever you want, no issue. But here voltages are known. Currents you can take 1 amp, no issue. Take 1 amp.